Lark Engineering. Complete feed mill engineering. In this video we discuss about quality premix procedures to enhance the feed performance.
Let me start with my presentation. I am going to share the screen. Sir, is the screen is visible?
Yes, it is.
Okay. Sir, I split my presentation into two parts. One is with respect to the technology and the machine, where we discuss about the different type of mixer that we can use in premix to make the premix or to make the feed. And then the second part is the key checkpoints with respect to the process and procedure. For example, in machine and technology, we will cover this is the a brief outline of the index that we have a small discussion in this presentation. Like in machine technology, the different type of mixers are double shaft paddle mixer, double ribbon paddle mixer, then single shaft paddle mixer, and conical blenders as per the application and as per the requirement we will discuss in detail. Then we will discuss about how to select a micro mixer for a feed mill. That is a very important criteria. Like a small feed farmer or having a very little requirement of a premix, if he uses a big batch mixer, he may underfill the mixer and can get poor mixing. And if a big feed miller uses a small batch mixer and overfill the mixer as per the batch requirement, there is also not good mixing. Then how we can select a perfect batch mixer for our feed mills. Then we will discuss about how to check the mixer efficiency and what is the coefficient of variation, and how we can compare the different mixing efficiencies of the different variants of the mixer. Then we will discuss the key checkpoints, the process and procedure, what will be the optimum filling level of the mixer to achieve maximum efficiency or to achieve minimum CV. Then use of carrier and base material in the premix to make the complete batch. Then there is very important point like dry and wet mixing cycle. As dry particles are free to move with respect to the turbulence and the mixer force, but the wet particles are not so much in the free movement in the mixing process. So we have to take care of the dry and the wet mixing cycle that we will discuss in detail. Then the interlocking sequence to avoid the underdose and overdose of the premix in the feed mills. And the one new thing we introduce in the premix process, that we must ensure that the bag prepared for the pre-starters must go in the pre-starter batch. So how we can avoid the cross-contamination, that the pre-starter premix node goes to the finisher or the starters, we can avoid with that PLC controlled barcode scanners, very low in cost and very cost effective thing. Then how we can ensure that the premix that we made in the mixers, the actual amount of the weigh that required is the technician and the operator putting in the feed mixer. For that we can discuss over the load cells and the tolerance of the weight in that mixing process. Then other one is the how we can select the appropriate batch for a better material weighing practices with respect to the fraction and the ratios. The other one is the mixer cleaning. That is very important part, because the residues in the mixer may create the dead spots in that mixing process. And also the one thing I want to add, the sequence of the ingredients, like when we, during the premix process, when we have to put medicines, the trace minerals, and when we have to put the base material or the carrier, so that we can have a better mixing efficiency. Then with respect to the machine and technology, what we have to check during the mixing process, the clearance between the mixer ribbon and drum, as there is a 8 to 10 mm clearance between the mixer ribbon and the drum. So we have to monitor regularly the clearance so that even the last 10 mm layer of the premix is homogeneous in nature. Then to check the dead corners of the ribbon, shaft and the drum. Then the very important part is the pockets at the discharge. The pockets at the discharge in the mixer obstruct the movement of the particles layer near to the discharge gate. So we have to avoid the pockets to get the homogeneous mixing. Then the next is the double gate mechanism to avoid the spillage of the medicines due to the back air pressure of the mixer while charging to the medicine hopper. Then the last one is the variable pitch or small screw dosing feeders for the dosing in the if we have to put the medicines in the auto mode. For example, we have to avoid the manual dosing and we have to put all the medicines in the mixer with the PLC control automatic system. So this is the brief overview of the presentation. Let me start with the mixing process that actually, as we all know, feed is generally considered to be the major input of the livestock and may account for the 70 to 80% of the production cost. So if we can produce high quality feed in economical way, it will not only cut the cost of production, but also yields high profit. In tomorrow's presentation, we discuss regarding the complete process and the process parameters of the batching, grinding, mixing, conditioning, pelleting, crumbling, screening. But today we mainly focus over the mixing process. This is the general flow chart of the feed mill process. For example, the raw material, then cleaning to remove the cobs, stone, jutes, then the batching process. After batching, we have to reduce the particle size in the grinding process. Then comes the mixing process, where we add the vitamins, minerals, oils, all things. So today I'll just focus on this mixing and the premix process. So as there are many types of mixer like double ribbon, double shaft, single shaft, or vertical mixers and conical blenders, I mainly discuss regarding the two designs. The one is the ribbon mixer, double ribbon mixer, and the other is that double shaft mixer. In double ribbon mixer, this is a U-shaped mixer. You can see this is a demo. We put colored sawdust with 4 colors and divide the layers into the 25% of each color, the red, green, blue and yellow. And then we start the mixing process. You can see in double ribbon mixer, one ribbon pushes the material from left to right and the other ribbon pushes the material from right to left. And like this, in this process, we can get a homogeneous feed. This is a process of a double ribbon screw mixer. Then in double shaft mixer, this is a demo of a double shaft mixer. What we did, this demo we did around 3 years back. We took 1 kg of colored rice and put into the 100 kilograms of white normal rice in that mixer. Then we run the mixer, and you can see this is after 2 seconds, after 3 seconds, 5 seconds and 7 seconds. So this is the homogeneity of the dispersion of the particles. Double ribbon is equally good as the double shaft. The only main difference is In double ribbon mixer, the mixing time is around 5 to 6 minutes. And the CV we can achieve around less than 5 in premix addition and less than 7 in direct 25 grams addition of the trace minerals or the premix. In double shot pedal mixer, the mixing time is only 60 to 180 seconds, like 2 to 3 minutes. And CV we can achieve less than 3. And the main advantage of double shot mixer is if there is variation in particle size, and there is variation in the density of the material, double shaft mixer is best suited for that application. Even for the variable particle size, variable density, we can have a good mixing in the double shaft mixers. Then the other mixers are the conical drum mixer, the vertical mixer, the pedal mixers. These are the other mixers. Like in conical drum mixer, the drum moves and mainly the material mixes through the gravitational forces. But that is only suited for the particles having equal size and the equal density. If there is a particle size variation and the density variation, then due to the gravitational forces, the heavy particle will settle down early, and the light particle, there may be variation in the mixing process in the conical benders if there is a wide variation in the density and the particle size. So we have to check the application, the particle size, the density before selecting the mixer. Then the next is how we can select a micro mixer for a feed mill. Let us assume a feed mill producing 150 metric ton of feed, and its premix requirement is around 3%. So 150 into 3% is around 4.5 metric ton per day. Generally, the feed millers have a manual premixer. That means they weigh all the items, the ingredients, the vitamin, trace minerals, all other things manually, put into the mixer from the top manually, and back from the gate manually. So that mostly 70 to 80% of the feed mills have the manual process. Only the big feed millers or having a commercial premix suppliers like Avitech, Newtech, and all other premix companies, and the feed millers having 7 or 8 feed mills and have a centralized premix plant in a location. They also have automatic projects. But in the manual operation, what we calculate that ideally the operator or the technicians, the labor may take around 8 to 10 minutes to charge the mixer manually. They have to go to the floor by the ladder and put into the mixer. I'm not calculating the weighing time. Weighing team, maybe we have to assume a separate team. So if we assume the 10 minutes filling time and 6 minutes mixing time, that depends upon the mixer design. Some mixer have 3-minute mixing time, some have 10 minutes. I'm assuming 6-minute mixing times and 6 to 7 minutes manual bag filling time, plus 3 minutes extra buffer time. So total batch time is approximate 30 minutes. So we can produce, if I have a 500 kilogram mixer, we can produce 1 ton premix in 1 hour. So for a 150 ton feed mill having requirement of 3% premix, we can easily produce a premix of 2 days in 8 running hours with a 500 kilogram mixer. Even from the small feed requirement, for example, 50 ton, 40 ton feed mill, there are different sizes like 50 kg mixer, 100 kg mixer, 300 kg mixer. There are different variants of the feed mixer. And one thing more, few feed millers are practicing 2 premixers. One is pre-premixer of 50 kg for the costly medicines and the trace minerals. And the second, a pre-mixer of 500 or 300 kilograms. What they do, they make a premix for the big premixer. For example, the costly medicines and the medicine having very less in quantity, for example, 40 grams, 50 grams, 30 grams, they make a separate premix and then put the complete bag into the premixer. Then that premix they put into the feed mixer in the feed mills. So that is the general practice few feed millers are using to get the mixing efficiency and to utilize the medicines, the costly medicines to maximum extent in the feed. Then this is the selection of micro mixer for the feed millers. Then there is a selection of the premix project for the premix suppliers. That is a big topic we can discuss separately because it is the totally machinery related. The automatic bins, the premix dosing, the auto dosing liquids, and the automatic bagging machines. And even in automatic bagging machines, we have a provision to check the weigh tolerances, all other things. That is the totally machine related part. Then we comes to the how we can check a mixer efficiency and what is the CV. For example, in a double ribbon mixer, I said that the CV is less than 7 or less than 5. In double shaft mixer, the CV is less than 3. But how we can check the CV of our mixer in our feed mill? Each feed miller, each premix supplier can check the efficiency of their machines. What we have to do, one method is the salt analysis and the other method is the micro tracers. I discuss about the micro tracers. What are micro tracers? Are color coated iron particles. What we have to do in 100 kilogram in 1000 kilogram batch mixer, we generally add 25 grams of micro tracers. Then we mix the whole batch for 5 to 6 minutes. Then after the mixing process, we collect samples from different locations. And from those samples, we separate 100 grams because average diet of a bird is 100 grams. We have to check that in that 100 grams is the presence of each and every nutrient, every ingredient, every oil that we put into the mixer. We have to check in that 100 grams. So we separate the 100 gram samples. We put the 10 samples into 10 jars. And we put a filter paper above the jars and magnet behind the filter paper. We shake the jars for 10 to 15 minutes. All the iron particles that recovered from the samples, they sticks to the filter paper. The micro tracer particles are very difficult to count with the naked eyes. We have to put a ethyl alcohol or any spirit so that they leaves the red color over the filter paper like this. This is the micro tracer. And when we collect the samples, there are like these spots on the every sample. And what we do, from the 100 gram samples, we count 45 spots from the first sample, 40 counts from the second sample, 42 counts from the third sample, 40 and respectively from these 9 or 10 samples, we count the different micro tracer count. Then we sum all these figures and divide by the number of samples, we get the mean. We have to put the mean into this formula. X1 is the first count is 45. This is 45 and the mean of all these 9 readings will be around 42.44. So when we put this in this formula, this is 45 minus 42.44 square plus second reading minus mean square, like this for all 9 readings. we get the standard deviation. Then we divide the standard deviation with the mean, we get the coefficient of variation. Like this is the report of the mixer that we did in March 2014 for mixer testing. We collect all these samples, we count these 9 readings, and we get the standard deviation of 2.96 and coefficient of variation 6.9. We can also have a ready formula like this Excel sheet. We can add all the readings in this Excel sheet, and automatically with the help of the formulas we get the coefficient of variation. So this is very simple method to check the coefficient of variation at our own feed mill. We can also provide the micro tracers complete guideline, and we can also do the feed mill audits to check the efficiency of the mixing efficiency of the machines. Then we come to the next part. The next part is the key checkpoints for a better premix practices. The number one is the filling level. This is a view of 2 mixers. Always ask your supplier that what is the supplier of the machine. Always ask your machine supplier that what is the minimum and the maximum level we have to maintain for ideal mixing. Let us say this is a ribbon mixer side view. For this we have to maintain minimum 40 to 45% of level, and maximum up to this 80% level. So if we overfill the mixer up to the maximum level, we can't get good mixing. The top layer of this has the minimum turbulence and mainly floats over the surface, so we get the poor mixing if we overfill the mixer. Same in case of the minimum level. If we fill the mixer below the minimum level, there is not appropriate weight of the feed particles to the last layer, and last layer as discussed earlier, there is around 10 mm gap between the mixer drum and ribbon, and that layer at that 10 mm only moves due to the weight of the above material and cohesion between the friction between the particles. So if the filling level is very less, there is very less movement at the last layer, and you do not get the homogeneous feed in that last layer, and the element of the medicine or mineral present in that last layer, or that we add firstly in the batch, there may be the mixing issues if we underfill the mixer to the below the minimum level. So we have to ask our supplier that what is the ideal filling level of the mixer, so that we can have a good mixing. Then the second is the use of base material. For example, we have a 500 kilogram of mixer, but we have a premix requirement of only 200 kilograms for that day, and we want to produce premix for that day only, because next day we have to run the separate recipe. We have a schedule of that 200 kilograms of the premix requirement. So how we cope up with that situation? What we have to do, we have to add base material or carrier like the grounded maize, rice bran, and we have to ask our nutritionist that what base material best suited for this recipe, because there is a specific properties of the base material and requirement in that premix. So we have to ask our nutritionist that in this batch, if I have to make 500 kilogram or 400 kilogram premix, but I have only 200 kilograms of the trace premix or the minerals, which base material I have to add so that I can get a proper mixing. So we have to use the base material to complete that batch. And the third important point is the material sequence. For example, the mixer have dead corners or dead spots, like this one. This is a photo of a uncleaned mixer. There are the dead spots. If we put small, for example, we have to add to 500 kilogram batch of a premix, there is any medicine which is only 40 grams or 60 grams. If we put that medicine initially to that mixer, in the empty mixer, the medicine may stuck to these dead corners. So what we have to do, we have to fill the mixer firstly with the base material or the macro elements that is more in formulation, and with the decreasing order, the trace minerals and the small quantity medicine lastly to the batch, so that there is not any dead spot, and the medicines or the trace minerals not get stick to that mixer ribbon or the shaft or the dead corners present in the mixer. So that is a very important point to be taken in care regarding the material sequence. And the other point is the dry and wet mixing cycle. Dry ingredients mix more efficiently than wet ingredients, because wet particles do not move as freely as dry particles. Therefore, the time frame for adding liquid to the mixer should be given careful consideration. This is a view of a mixer scheme. First, there is batching, grinding. This is the mixer line. After mixing, this is pelleting and the bagging. We'll discuss about this mixer line. So in mixer line, these are the oil tanks at the top floor of the feed mill. This is the batch bin above the mixer. This is the mixer. This is the medicine hopper. And this is the service tank for the oil. If firstly the feed comes from this batch bin to the mixer, we have to take care that firstly we have, before the oil addition, before the liquid addition, we have to add the medicines and to give a dry mixing cycle of 2 to 3 minutes depending upon the mixer design. Always ask your supplier, a machine supplier, that what is the dry and wet mixing cycle of your mixer. Because if we add oils before the medicines, the premix may sticks to the wet spots of the oil, and there may be not good free movement of the particles. So we have to, firstly we have to add the medicines into the mixer. Then after the dry mixing cycle, we have to add the oil and the other liquids. So this is very important part. We have, and even we have to check in the automatic feed mills this interlocking sequence of dry and wet, but we have to aware to the technicians and the feed mill operators in the manual projects where there is no automation. They should be that much aware that they have to add the medicines, and after the dry cycle of 2 minutes we have to add the oil. Even I suggest the feed millers, even in the manual, as there are 30 to 40% manual feed mills in India. From the 1500, if there is a 1500 feed mills in India, around 600 to 700 feed mills are semi-automatic or manual. So even in these manual feed mills, with small investment, we can add that interlocking scheme, footer system, siren system, and the interlocking of the gates, so that we can achieve a good mixing premix practices even in the manual projects. So we have to take care of this dry and wet mixing cycle, and also to reduce the oil or liquid addition time, we can spray or put the oil into the mixer forcefully with the help of the feed pumps. Most of the feed mills, there is the oil addition is by gravity, and by gravity it takes some time to put into goes into the mixer. So that time we can reduce with the help of a feed pump or the pressurized forceful addition of the oil or liquid in the mixer. That enhances the mixing efficiency and reduces the time required to add the oil or liquids into the mixer. So that we have to take care of the dry and wet mixing cycle. Then there is an interlocking scheme in the feed mixing process. In most of the feed mills, we got the feedback from the feed millers or the managers that if a technician or operator mistakenly forgets to add the premix in a batch, and after 3 or 4 batches he came to know that I mistakenly didn't put the medicine in the previous batch. What he will do, he will add 2 batches of the medicine in the next batch to complete the count, because he knows my manager provided me the 10 bags of the medicines for the 10 batches. If he forgotten to add the medicine in one batch, then what he will do, he will put 2 bags in the next batch to complete the count. So what we have in this automation sequence, if we add the medicine from that medicine hopper and there is still batch in the mixer, the time when जब तक ये मिक्सर का बैच सर्च बिन में नहीं जाएगा, for the next batch gate will not open to add the medicines again. And if अगर इसमें बैच रुका हुआ है, तो अगर इसमें हमने मेडिसिन डाला, जब तक ये बैच आगे नहीं जाएगा, दूसरी बार मेडिसिन डालने के लिए ये गेट नहीं खुलेगा. इंटरलॉक, न्यूमेटिकली इंटरलॉक्ड विद द स्लाइड गेट ऑफ द सर्च बिन. एंड अगर एक बार मेडिसिन चला गया, जब तक ये बैच इसमें अंडरडोज भी नहीं होगा, ओवरडोज भी नहीं होगा. So that is the thing we keep in that interlocking sequence to avoid the under and the overdose. So this is very important point in the feed mill process. Then the other process is the barcode scanning. In this barcode scanning, for example, we provided the 10 batches, 10 premix for the pre-starter, 10 for the starter, and 10 for the finisher to the feed mill operator or the technician. But how we come to know that he puts the pre-starter medicine in the pre-starter batch? So what we can do, we can add the barcodes over the pre-starter bags, starter bags, and the finisher bags, and we can save that barcodes coding in the PLC. If the pre-starter recipe is running and mistakenly the technician grabs a starter bag and try to scan with the barcode scanner, medicine hopper will not open. Medicine hopper will only allows him to add the medicine if he picks the right bag with respect to the recipe. So that we can check with the cross-contamination of the different type of medicine in the feed. Then after this, the next process is of mixer cleaning. Generally, there is 8 to 10 mm of gap in the ribbon and mixer drum. When we are adding liquid medicines or the oil in the mixer, the layer of a moist medicines and the feed particles keeps on depositing between the ribbon and the drum, and the clearance of 8 to 10 mm goes on reducing with the time. So and also these residue material in the mixer obstruct the mixing process, as the turbulence and the flow and the movement of the material will reduce due to the residue of the material. So we have to take care of the mixer cleaning process to achieve maximum efficiency and the good mixing from the premixer. Then we'll discuss regarding the machine technology. In machine technology, this is the side view of a ribbon mixer, and here we can see a layer of the material between that 10 mm gap between the ribbon and the mixer. we have to take care when we have to change the medicine from the pre-starter, starter or finisher. If there is any that type of medicine that is not suitable for the other recipe or the other formulation, we have to clean that leftover material from the service of the cleaning windows after the complete batch mixing. And if we have to make other recipe premix, we have to clean this leftover material from the mixer. Then you can see where the ribbon and the shaft connects, there is a corner like these. But we always check with the machine supplier or with our mixer that we have to avoid these dead corners. We can fill it with the welded material. We can fill this gap and make them finished surface to avoid the dead corners and the dead spots in the mixer that may obstructs in the mixing process during the premix manufacturing. This is very important part, the pockets at the discharge. This is a side view of a slide gate below the mixer, from where we discharge all the material during the bagging. You can see where the slide gates and the outlet, like this is the outlet, from this is the inner view of from the top of the mixer. If there is a pocket at the discharge, as the mixer rotates from ribbon rotates from this part to this part, this pocket will obstruct the layer near that pocket, will be in very less movement with respect to the other material. So we have to check the machine for these pockets, for these dead corners, so that we can have a homogeneous mixing in the complete batch. Then this is the view of a medicine hopper above the mixer. Generally the medicine hopper is in only single gate. We have a one gate at the top of the medicine hopper. But what happens when the mixer is running, there is a back pressure of the air from the mixer ribbon, and the nature of the air that escapes from the open areas. So when the time the operator or the supervisor is putting the medicines into that medicine hopper, the back pressure air from the mixer obstruct in the process, and there may be 5 to 10% of, maybe 2%, 3%, depends upon the pressure and the angle of putting the material. There may be wastage of the medicines into the air, or maybe spillage of the medicine near the medicine hopper. So what we have to check, medicine hopper must be equipped with the double gates, one gate at the top and other gate at the bottom. When we have to put the medicines into the medicine hopper, this gate is in closed position so that no air comes from the bottom of the mixer. When he completes the charging of the medicine hopper, we have to close this gate and we have to open this. Even we can have a pneumatic slide gate or we can have a rack and pinion gate. We have to open this gate and all the medicine goes to the mixer with minimum spillage and the minimum wastage. This is the brief discussion of the machines in the manual dosing. And in auto dosing, in the big feed mills, if we want to avoid this manual dosing, because this is all man oriented, labor oriented work, that how is putting into the medicine hopper and how is going to the feed mill, we can have a auto premix dosing system like this, like this. This is a auto premix dosing system. We can have a two premix bins at the top floor of the feed mill. We can charge this with different premix, complete premix, and as per the formulation and as per the recipe requirement, all these premix goes to this load cell based way hopper, and this way hopper as per the command from the PLC guides the premix directly to the mixer, automatically maintaining the dry and wet cycle, automatically maintaining 0.25% weighing tolerances, and totally this is automatic PLC control system with the reporting system. So this is a brief discussion regarding the premix practices that we may practice to enhance the premix performance in the feed mills. So thanks a lot to all audience, and if there is any questions we can discuss.
Yes, thank you very much, Mr. Harjot Singh, sir. And if there are any questions in mind, dear participants, you can please put it in chat box, or you may simply unmute your microphone and put your question.
I want to ask about the timing of mixing. How to decide the timing of mixing, and the timing of timing of mixing will change depending upon the recipe.
Thank you, sir. Thanks for that question. Sir, the timing of the mixer firstly depends upon one is the mixer design. For example, if I assuming a single recipe for the all mixers, the timing for the double ribbon screw mixer will around 4 to 5 minutes. The timing for the double shot pedal mixer is around 2 to 3 minutes. And there are conventional vertical mixers. हमने देखे होंगे बहुत bottle type vertical mixers.
Yes, बहुत पुराने जमाने में होते थे.
जी. The timing of those mixers is around 25 to 30 minutes.
Yes.
That totally depends upon the mixer design, and फिर उसमें अलग अलग आ जाते हैं सर. The particle size, the variation, the density. In few cases we observed अगर एक बहुत ज्यादा वेरिएशन है डेंसिटी में, एंड एक मिक्सर में हम बहुत ज्यादा मिक्सिंग टाइम दे रहे हैं, देन ड्यू टू द ग्रेविटेशनल फोर्सेस एंड द डेंसिटी सेपरेशन एक लेवल के बाद हमको कुछ डीमिक्सिंग भी ऑब्जर्व हुआ. सो दैट टोटली डिपेंड्स अपॉन द मिक्सर डिजाइन एंड द पार्टिकल साइज एंड द मिनिमम टू मैक्सिमम रेंज ऑफ द इंग्रेडिएंट्स. सो फॉर एग्जांपल अगर हमको सिर्फ डीसीपी, एलएसपी और माइक्रो इंग्रेडिएंट्स मिक्स करने हैं, दैट इज मोर देन 100 किलोग्राम्स डोज इन 1 टन, उसको 2 मिनट में भी वो मिक्स हो जाएंगे. बट देयर आर ट्रेस मिनरल्स 40 grams, 30 grams present in that dose. For that we have to increase the mixing time so that we can achieve maximum results and we can get the minimum CV. So that totally depends upon the mixer design. Also एक कंपनी का डबल रिबन मिक्सर का टाइम अलग होगा, दूसरा कंपनी का डबल रिबन मिक्सर का डिजाइन अलग होगा, बिकॉज द width of the ribbon, the RPM they follow. कुछ some works at the 30 RPM, some works at even 40 or 45 RPM. फिर the turbulence of the material कैसे in or out flow कर रहा है, कितना width का pitch, कितना हमने कितने फर्स हमने दिए हैं, कितने पिच दिए हैं. सो वो टोटली सब्जेक्ट ऑफ द डिजाइन एंड द डिफरेंस इन द मशीन्स. सो उसको फिक्स करना बहुत मुश्किल है. भी अगर रिबन मिक्सर है उसको 4 मिनट फिक्स करना बहुत मुश्किल है. दैट टोटली डिपेंड्स अपॉन द मिक्सर डिजाइन एंड द इंग्रेडिएंट्स बिहेवियर.
So I think in that case, like for example, in my case, I make 5 kind of mash feed.
Yes, sir.
For me, the timing of the mixing will be different for all type of feed.
Sir, we can check what हमने अपना फैक्ट्री में क्या किया. हमने डिफरेंट टाइप्स ऑफ फीड ली और उन्हें डिफरेंट टाइम दिया. 2 मिनट, 3 मिनट, 4 मिनट, 5 मिनट, 6 मिनट, एंड 6 के 6 सैंपल्स को हमने सीवी टेस्ट किया. The only process to check the mixing efficiency at different minutes and different feed behavior, हमको आपको 10, 15, 20 sampling लेकर different times पर और different formulations पर we have to check the CV. That is the only method we can identify the mixing time with respect to the grains.
No, actually, that is what we have given. We have, like, initially what we do this kind of practice every year, because wear and tear happens in all the mixer, and also and also the what you call the raw material also quality also keeps changing. Raw material, what you call that. Number of raw materials,
their density, particle size, moisture.
So basically what we do, we only check the salt content in those 20 samples. That salt content tells us the CV, because we know what is our salt content in formulation and what is our salt content in the feed. That we somehow have to correlate, because itna minutely uske upar jana, like, for a small farmer, like,
yes, sir.
It is very difficult.
Sir, we can arrange a visit at your place, and the micro tracer kit is very small. We can carry with us, and we can
micro tracer it is 100% accuracy will come.
Yes. Sir.
I have also seen a micro tracer with an emblem of Pfizer on each and every micro tracer.
Yes, sir.
I mean, that micro tracer, if you see in that, what you call that microscope, you will come to know the Pfizer emblem on each and every micro tracer. I think it was having 6,000 particles per gram.
Yes, sir.
That was given to avoid the, what you call that, brand image. Like, for example, if you are selling Bicasol capsule, like if you are selling, like, for example, if any feed miller, very big feed miller, if they want to, like, avoid some duplicating by somebody else, so they can add micro tracer in their feed, and they can check the micro tracer with they also give you some kind of magnet which gets attracted to those micro tracer, and when you see the micro tracer, उसमें वो उसका आपका emblem भी नजर आ जाएगा. That's something fantastic. But I think, do you recommend to use VFD in place of your क्या उसको बोलते हैं? I mean, is that VFD is far better than using your normal that
VFD, variable frequency drive.
Frequency drive, variable frequency drive. Do you recommend to use VFD in compare to our
VFD in which machine? Hammer mill or mixer?
No. In grinder.
Yes. In hammer mill, actually, sir, VFD has a very good role to achieve a particle size as per the requirement. For example, for a pellet feed, the broiler feed, the tip speed of the hammer mill we require very on a high tip speed we require for the broiler. So if we have to produce from, for example, someone having a 10 ton per hour broiler feed mill, the motor of HP of the hammer mill is around 150, and the RPM is of hammer mill is around 2800 RPM, because in broilers we require grinding at 3 mm or 2.8 mm screen with a particle size less than 900 microns, more than of the 80% of the average. If we want to produce mash or breeder feed from the same hammer mill, even if we use a coarse screen, for example 6 or 7 mm screen at that higher tip speed hammer mill, we will get 15 to 25% of fine dust of below 300 microns. That is not suitable.
Maybe more than that.
Yes, exactly. Maybe 25-28%. That is not suitable for the breeder mesh or the layers. So what we do in that case, instead of putting a separate hammer mill or smaller hammer mill, instead of investing more on machine, we reduces the RPM of the hammer mill from 2800 to 1800 or 1700.
No, that you can do it even to what you call the 1837 also.
Yes.
I mean, it to that micro level you can go.
So by reducing the RPM with the help of the VFD, we can reduce the tip speed, and we can even at 1200 RPM or 1400 RPM, hammer mill is not able to prevent the 100% dust. You can reduce the dust from 25, 28 to 5, 7, 10, 12% with the help of the VFD. VFD is a very good application in hammer mill that we can use with respect to the grains and all other.
I think only with the help of VFD you can control the particle size.
Yes, sir,
otherwise
exactly,
normal जो फीड मिल है जिसका आरपीएम तो जो मोटर डिसाइड करती है या मैक्सिमम पुल्ली डिसाइड करके आप उसको कम ज्यादा कर सकते हो unless you know what RPM is required. But like for example, now when I'm making 5 feed, if I need 5 RPM for the particle size, yes, I will not invest 5 machines. Instead of that, 60,000-70,000 रुपए की एक VFD लगा दो, and then every starter and pre-starter just change your whatever that RPM speed, and you can have the same you can have different particle size from the same feed mill with the same VFD.
And also, sir, in feed mills, we suggest feed mill at hammer mill, VFD at hammer mill, and VFD at hammer mill feeder that controls the feeding with respect to the load on the motor. And then VFD at crumbler feeder, then VFD at the very important at blower that reduces the power consumption and helps to cool the feed with respect to the season and the moisture content, because in blower there is only damper setting for the cooling, but with the help of the VFD we can change the impeller RPM and get the desired suction with respect to the moisture content of the feed. So we have 4 to 5 applications machines of the VFD.
Actually, I was trying to share, I will share one of my experiment we just did last month. I will share with everyone who is participating here. And the same question I asked: is there any practice to reduce that black particle of black corn, which is full of aflatoxin corn in our maize, in spite of buying a good quality of maize, in spite of having vibrating sieve, but still that vibrating sieves का जो काम है, it is only the foreign particles निकालना, like whatever less than this and less than that करके निकालना या more than that करके निकालना, उसका सिर्फ यही काम बनता है. उसमें हमारा foreign particles कम हो जाता है, उसमें definitely around 1.7% तक हमारा particle size बाहर मतलब waste foreign material निकल जाता है, but energy and other nutritive value increases by more than 3%. That's a different issue. But what we did was we attached one additional table which is in a slanting mode from that sieving machine, from that vibrating sieve to the inlet of grinder, where we employed 3 people to pick and choose. Let it be 70% and 80%. Let it be 60%. Only those black particles manually. I am just talking about manually. We did this trial, and that after that trials were conducted, the aflatoxin level in not sorted feed was more than 50 ppb, and in sorted it was 11 ppb.
Sir, actually, we are in discussion with one of the color sorting machines supplier. Because for the big feed millers and the conveyors having the conveying capacity of 30 to 35 metric ton per hour, manually we can have a trial and we can get the results, and this is very good feedback from your side, sir. But in big feed millers and the big volume of the grain, we have to deploy the automatic machines, and we are.
What could be the cost of those machines?
Exactly, sir. We are in discussion, and we are working over that, because we have to check the feasibility of that machines too, because they are mainly used in the rice mills to separate.
I know. I have seen it in Karnal.
Yes. So we are working over the feasibility of those machines in the feed mills, and with respect to the benefit and the investment, or the return over investment, then we can have a brief discussion that whether they are viable to put those machines in the feed mill, or we have to check with some other process. Yes, sir.
Actually, it is 100% viable. Actually, let it be very honest. Maybe few years back, we did not know the damages done by the aflatoxin to our chicken. To what extent? Now every damage is quantified and rupeefied. When I say rupeefied, उसकी rupees में या dollar में उसकी value निकाल ली गई है. Because of that, now it is viable to buy any machinery, because that machinery will have a one-time expenses, but at that one-time expenses, let it cost maybe 20 rupees per ton or 30 rupees per ton or 70 rupees per ton. But we will ultimately, we will, what you call that, save lot of money in our, what you call that, broiler feeding cost. Our FCR will automatically come down by introducing mycotoxins of PPB level is reduced to a like very larger extent.
Thank you for the valuable feedback, sir. After getting the feedback from those machine suppliers, we'll discuss in detail, sir, that what will be the possibilities, sir.
I must thank you for your such a valuable valuable details and all the information given. As I have also written in the chat box, I mean, it is still an eye opener in spite of doing poultry farming for last 40 years and having feed mill for last maybe 30 years. It is still like, we still have to learn so many things from our young generation. Thank you, and keep it up.
Thank you very much, Harjot Singh sir, and thank you very much, Onkar Singh sir. We are actually very blessed to have participants like you, and like the other participants like Dr. Praveen Singh, Bharat Gautam sir. It's because of your interaction and because of your questions, we are learning many practical things in poultry nutrition, which were beyond our imagination. Thank you very much for such
Actually,
beautiful questions.
doctor, I will like, if you go and see what lectures you have kept for those 6 days, I am very, like, very honestly, I mean, let me be very honest, I'm still sitting in a boxer and a banyan to see your show, because I got up little late. I didn't get time to go to, like, to have my bath, and because it is Zoom, I can sit in whatever manner but I've been following this for last 3 days, and I'm following it continuously for all whatever 6-7 hours. I'm really, you are putting the great work, like, giving this kind of what you call that, lectures, and I'm so thankful to the speakers. They are sharing their so much of information to us, like, I'm so thankful to that.